In the face of an unpredictable future, we are all called upon each and every day to think of out-of-the-box ways to tackle challenges to our environment, well-being, or how to park your car near your local drain without getting arrested. Welcome to the Grand Challenges Podcast, a show about inspiring individuals who are stepping up to these challenges and are here to share stories about their own personal journey towards making our world a better place. I'm your host, Peter Marcus Bach, a former PhD student filled with nostalgia and a passion for connecting across expertise and providing you access to knowledge from the cutting edges of science, engineering, technology, and design. My guest today is Professor Anna Deletic, the Executive Dean of Engineering at Queensland University of Technology, Australia. Anna is perhaps the most prolific researcher in urban stormwater management across the world, with a diverse portfolio across water quantity and quality, modeling, and most notably, nature-based solutions. Today on the show, I reconnect with my former PhD supervisor as we retrace Anna's journey along what she describes as an infamous pendulum from former Yugoslavia to Australia. We explore Anna's impact in water-sensitive urban design, good modeling practices, women in engineering, and her incredible mentorship advice. Detailed information is provided in the show notes over at petermbach.com/podcast. Thank you for joining, and please enjoy the show. Hey listeners, just before we begin, here are 3 quick things to be aware of. Firstly, we recorded this show in Anna's office and noticed during the recording that our chairs were quite lively and rickety. So you may hear some additional sound effects during our conversation, which hopefully will not detract from your enjoyment. Secondly, there are a lot of different terms for nature-based solutions or water-sensitive urban design, as it is widely known in Australia, thrown around in the episode, including blue-green systems, green-blue systems, green infrastructure, and so on. Anna also says WUSUD, which is simply the phonetic pronunciation for the Water Sensitive Urban Design acronym, WSUD. Just making sure you are aware of this so that you don't get confused. Last but not least, Anna reflects on the many collaborations she has had and mentions many people mostly by their first name. The show notes provide a summary of all the people she mentions, so if you would like to know more about them, do check out the show notes. With that out of the way, let's now get to the show. Welcome to the show, Anna.
I'm very delighted to be here.
It's a big moment for me. In fact, I've had a lot of people tell me to get you on the show. So looking forward to sharing this moment with my PhD supervisor. We've known each other since 2009 when you first came to me and said, would you like to do some research in stormwater? And it got coupled with a trip to Japan. So I remember that moment where I thought, hey, why not? I think I had just done urban water management as my undergrad subject and really enjoyed it. So big moment. And now we're sitting here in sunny Brisbane having a chat. Also with a bottle of Coke, which I brought you.
Thank you.
Cheers to this moment.
You know how to bribe me with Coca-Cola.
Well, I only learned from the best. So, in a way, this is the perfect segue to talk about how my research career began. And that was, I was sitting in your office on one of my first days as a summer research student, and you were there with David McCarthy, and we were talking about the first flush in urban stormwater runoff. And both of you decided to make bets about what my research results would be. And the bet was a 24-can crate of Coke.
Of course, it was very normal in my group to bet over research questions and hypotheses.
And at that moment, I realized it was not going to be a series of stereotypes of research. It wasn't going to be this kind of bland thing. I was definitely in for a ride. So
thank you.
Yeah, that was definitely a very memorable moment.
Golden days of our group. We had, I think, almost 40 people at some point in our group. So it was lots of fun. Lots of betting.
And by that stage, you were at Monash doing research into water-sensitive urban design and urban stormwater management. But that's not where you actually began. You came from Serbia, you did your PhD in the University of Aberdeen, and you were actually on the hydraulics side. But I guess before we even get into that, engineering, what made you think to go into engineering?
I come from a long line of engineers. My grandfather, my father were engineers. And even my husband and my sister are engineers. My daughter, who just finished engineering, is 4th generation of engineers on both sides because my mother-in-law and my father-in-law are also engineers. So basically, as my daughter keeps saying, we are genetically modified. We can't do anything else but engineering.
And I guess you wanted to follow the family tradition, the family line, and decided to do that.
It's actually just normal in our family to become an engineer. You can rebel and do physics like my son. And there is one also person who did chemistry. But I think that's kind of it. So we are okay with doing physics,
It's either the theoretical side or just apply it more.
It's my son who's finishing physics. It's actually general, but his master is more in theoretical physics.
Very cool. And so engineering, and you decided to then go direction water, hydraulics.
Yeah, because that's at the time when I was finishing, which was in end of 80s. I graduated in 1989. Hydraulics was the thing to do in water engineering. So I was, of course, civil engineer, but I majored in water because I found it more interesting and more fluid.
Pun intended. And so this was in Serbia at the time?
Yes, I was in Belgrade, University of Belgrade, which, of course, at the time was in old Yugoslavia. So Belgrade University was regarded and still is as one of the best places to study in that region. So it was pretty tough degree, but it was fun as well.
And then after that, you moved to Aberdeen to do your PhD?
No, after that, actually, I worked at the University of Belgrade for 5 years and I did my master. And master there was a combination of taught master and a big thesis. And my first papers, first flash paper was published for my master thesis. Actually, I published, I think, 3 or 4 journal papers, including water research papers for my master thesis. Because in those days, it was really full on. When I moved to Aberdeen, I moved because of the wars, because, in 90s, Yugoslavia went into flames. So my husband and I, we moved to Aberdeen and I got my first lectureship without having PhD, which was pretty rare. I was first female lecturer there in Cole College of Engineering. So I started lecturing in 1995 and started doing PhD. So I did full-time lecturing and doing PhD part-time for 5 years. And I graduated, basically submitted my PhD in 2000. So that's kind of journey.
It reminds me of a picture that I saw of you many years ago. Actually, I think it was from your time doing the masters where you were just coming out of a manhole doing a lot of that monitoring. I think we'll have to find that picture and put it in the show notes for the listeners to get an impression.
I used to joke, that's my modeling career because that picture ended up on some report. I can't remember, some European or UNESCO report. So I was saying I have a cover page, me coming out from a manhole.
Yeah, certainly very funny. And I know that a lot of us will appreciate that. I think they republished it a few years later at a conference, or at least during a conference visit. So definitely brings back, I guess, memories for you as well.
I was almost arrested because I used to park a small car in front of that manhole. And it's during the wars in Serbia. And it was so funny because I would just park the car to protect the manhole entrance, then go down and do my work. And one day I saw 2 policemen watching, saying, "What are you doing down there?" And I was like, actually, funnily, I never had an overall something. I was in normal clothes. I was like fixing some stuff. So they were very interested, but actually they were talking about how they may take me to the police station because I'm in the middle of a city going into a manhole. So it was fun. And it was during war, so it was a bit weird what you are doing in infrastructure as a lay person. So
I guess I'm just getting these images of something else that a mutual friend told us to inquire about. And this was also a moment where you accidentally backed into a policeman with a machine gun.
Yeah, that was kind of at the same place. It's called Miljakovac. It's a suburb where we had experimental catchment.
Okay.
And I parked again in the wrong spot. And I almost hit the policeman. Actually, I did hit the policeman. He was laughing at the end, but it was not fun at the time for me.
I guess at the time, a bit intimidating.
Yeah.
But we digress. But it's a funny experience, I guess, you always get when you have to collect your data out in the field. But this data then became perhaps one of your most influential papers in your early career, which was really about the first flush. And you looked at Miljakovic and Lund catchments.
Yes.
And so that was also one of the first papers I read starting my career. But I guess for the listeners, when they think first flush, they're probably going to be thinking something to do with toilets, but that's actually not the case. Let's maybe uncover a bit about what that is.
First flush is a phenomena which is basically when rain comes, it flushes pollution from streets. And of course, at the start of the rain, there should be more pollution. Therefore, you should see some sort of peak of pollution coming through. So it was a bit of, call it a myth that this is going to be a big thing. But at the end of the day, it turned out to be a lot about the size of events. So if it's a very long event, of course you see that. But there are lots of small events that are not able to flush all that dirt, the initial dirt. So as I said, it was the first paper where I was talking about these things, because before that there was just hypothesis. It should be first flush whenever it rains. So yeah, that was, and it was a single authored paper, because I don't know why, but when I moved to Aberdeen, I didn't have really supervisor for lots of stuff I was doing. So it ended up being stormwater paper.
But it came out in 1998, I believe?
Yes, because it came much later, because when I immigrated to Scotland, it took me a few years to learn to publish papers, because in Yugoslavia, again, we just didn't have that tradition. So no one really taught me how to write papers. And I still remember submitting that paper and getting these reviews when one guy said, this is really good work, but not well written. But the other two reviewers said, we have no idea what's this about. So it was so badly written. And then I had a very, very good mentor there called Professor Willets. And Professor Willets was not in my field. He was actually more into wind erosion. But he taught me how to write papers. So then I rewrote that paper and it got accepted. But I still remember rejection. And these first rejections were very hurtful, but they were also true. As everyone else, you need to learn how to write papers, not just do research.
I think it's the rite of passage for many researchers, where there's always your first paper, your first rejection, your first major revision, your first frustration with reviewer comments. What is this person thinking? But I guess we all go through that.
I must say I was not frustrated with the reviewers. I was frustrated with me, because at the time I just didn't know how to write, because we were never trained. My training in Yugoslavia was all about, I still remember, 5 years of degree with few words written. So there were no reports. We were just doing equations and doing problems, and there were nothing about how you write. And of course, know how to write a good journal paper.
Yeah, it's a bit of an art in itself. Other mentors of mine have also exchanged some interesting anecdotes about writing. And I guess a lot of that you've also passed on to me, and it's certainly a journey. But first flush, 1998, and almost 30 years after, I see that this myth still is being questioned today. I remember talking to a mutual colleague of us, and at a previous conference, this was up for discussion once again. So
it depends how you analyze data or what you are looking into, because if it's, of course, a very long, prolonged rain, you will see it. But if it's a very small event, you don't see that, because there is lots of pollution out there, and it's not easy to get exhausted. And then you have what's happening in pipes, and I don't want to bother you, but
well, you've already taught me hydraulics in undergraduate, but yeah. I guess the more current and the more exciting aspects came immediately after, with your journey to Australia and that interesting transition from pipes and concrete and hydraulics into the more softer side, namely nature-based solutions or water-sensitive design.
My PhD in Aberdeen, which I did almost non-supervised, because again, I had supervisors, but they were not in my field, so they refused to be on my papers for my PhD, was about grass whales. It was hydraulics. When you go and look, I developed this model about sediment transport in grass whales. But application was in green systems, which is grass whale. And that was the first thing I did in green systems. So when I moved from Aberdeen to Monash, Melbourne in 2003, it just was natural that I go more into that field. At that point, Monash actually was called depleted of water researchers, because quite a few of them retired or left. So when I joined Monash, I was almost alone there. And the only person that I found there was Tim Fletcher, who at the time was a research fellow. And then we basically start working together, and few years later, we had this quite big group with lots of PhD students like David McCarthy, and then yourself, Belinda, had. So it really flourished. Yeah, so it was fun. And it all became about WSUD, or nature-based solutions.
WSUD, water-sensitive design. Yeah. All the different terms. But what is the term you use now?
I actually like nature-based solutions the most, or blue-green systems, but particularly nature-based solutions, because it's true, these systems are mimicking nature to do whatever treatment. And at the moment, I'm a lot fascinated by impact of this system on flooding, because that's what's been missing in Australia for a long time. And we are finding that they can be used particularly for flash flood management. And since now I live in Brisbane is very flood prone. And if we protect our properties even from nuisance flooding, we are doing a lot.
I guess the nuisance flooding being enough to cause some form of damage, but not necessarily a loss of life. But this damage adds up over time.
Yeah. In Australia, even in big floods, loss of life is not that common in flooding. It's more about huge damages and cost of infrastructure and recovery and all that. And particularly the last flood, which happened just a year ago in Brisbane, was a lot about flash flooding, which means even if you were far from Brisbane River, you may have suffered because of huge overland runoff.
Yeah. And so I guess with nature-based solutions for this, we are talking the larger systems, or are we also thinking smaller footprint?
We can do smaller footprint, but lots of that, it's about storages, basically, again, going back to hydraulics. So we've done this work a few years back when we looked into impact even of rain tanks. And you can have, if every house got a rain tank, and if it's a leaky rain tank or even normal use indoor-outdoor, so we modeled impact on flood damages, and we found that in a small catchment, it can save up to 20-30% on annual costs in flooding. We modeled 85 years of 6-minute rainfall, because we developed this very fast flood model, cellular automata model that can give us that speed. So we can do 2D modeling of flooding. So yeah, in a way, I would like to see more of WUSUD in Australia being used for nuisance flood / flash flood protection.
And we certainly need it now. I guess Australia's gone through historically, well, I guess the time you arrived, it was going through the millennium drought, so floods wasn't a big concern. And instead it was more the water scarcity. And also, I guess in Melbourne's case, the water quality aspect.
Water quality aspects there all the time, and WUSUD's being used very well in Australia for managing that. However, this flood drought thing is a natural cycle in Australia. Australia has either too much of water. Like in the last 3 years, we had 3 consecutive years of El Niño, which means that's why we were flooded. But then it goes into droughts, and millennium drought was one of the biggest that we had. So in a way, because of climate change, we are having more of these extremes. Instead of 1 year of El Niño, we are having 3 years of El Niño in a row, which means flooding. Or we have, instead of few years of drought, we are having, like in that case, was almost 14 years of drought. So unfortunately, Australia is going to face more of these extremes and challenges. And I believe that green-blue infrastructure can be part of the solution. I'm not saying it's the only solution, but it should be used as one of tools or approaches that we should use to make our lifestyle livable.
No, very true. And I guess you say the key word there, livable. And it's really not just about the water management, but by managing the water, you actually create a range of other benefits.
Absolutely. We've done that analysis on benefits. And actually, the highest benefit comes from property values, particularly in Australia where property are so expensive. So if you have attractive neighborhood with attractive green infrastructure, you sell your property for far more money, and even, small percentage, like in Sydney, they found increase of 5-6%. If your place overlooks some green infrastructure, means lots of money, far more than you invest to build this system. And then comes flooding. That's the next one. So if you protect your property from flooding, then comes, of course, other aspects. Interestingly, pollution, but interestingly, this harvesting, stormwater harvesting would be mainly the smallest benefit in this order. So as I said, interestingly, the biggest impact is in property value rather than in water quality or water management.
No, very interesting. And so I guess one technology that you focused on quite substantially, especially in your time in Melbourne, has been on biofiltration systems or rain gardens, many different names for it, but really around the design of these systems, from the plant selection to the filter systems. I'd like to unpack some of that.
Okay, it was very interesting actually when I moved to Melbourne in 2003. As I said, there was very vibrant industry applications and there were lots of trials of WUSUD systems, but there was not much science, as I call it, proper science published in good journals. So what happened is, like, I still remember they had these guidelines which were built on people's hypotheses saying, let's do this and it should work. And at the time, I still remember I was at this conference in Lyon. I can't now remember. It was ages ago, very likely 2005 or something. No, before that even. When Bill Hunt presented some of the first rare monitoring of bioretentions in US, showing that they are exporting pollution. So there was more, particularly phosphorus, out than in. And then I was like, this is interesting. And we have these guidelines in Australia. Let's check what's going on with this. So we looked and we found it was the same. The guidelines which were kind of proposed, they were adoption guidelines basically, they were exporting pollution. But interestingly, at the same time, there was this hypothesis as well that every plant is a good plant. So the guidelines looked like use this media, put some plants in it, and that'll do the job. And they start building these things around Melbourne and even in Sydney. One of the first was built in Sydney. And I was successful in getting some nice money to test some of these things. So with some industry backing, Victoria government gave me my first big grant. And we really start looking into these, finding that the guidelines that were around were really wrong. First of all, the media spec was such that they were causing more pollution than treatment in many cases because levels of nitrogen and phosphorus were never kept in limits, but, it depended on application. So some people were just putting even compost in them, which meant export of pollution. But at the same time, we found that actually not every plant is a good plant. So we found that there are only few plants, at least from 20 we tested to start with, only a couple of were doing job. So that's how it all started. And then by end of this big project, we developed first set of evidence-based guidelines, which were very different from the original, which were saying, this is your spec, these are your plants you should use. However, nature-based solutions being nature-based, these guidelines made sense in Melbourne, and we could use it in Brisbane as well because we were designing systems using local rainfall. But the problem was they wouldn't work in Perth, for example, because Perth had different flora and fauna, and definitely even in some areas on the East Coast where there was not enough rain, plants would start dying. So what we learned in this process is, although we call them FOB guidelines, were pretty successful in some areas, they were not successful at all in very dry areas and far from Melbourne areas, if you know. So then we learned that, and we did far more research into different species and looking into how to make these systems more resilient. I personally think we are not there yet in many ways because, to be honest, in around 2010, 2013 or something like that, lots of money that used to go into engineering research just disappeared. In Australia, we had this wave of we've done everything in engineering. We don't have to invest in engineering research anymore. All money went into social science and adoption. So I personally think that there are so much more things to do in this space, particularly maintenance and tweaking them to work in a bit more challenging conditions. So I still think there is a lot to do, but as I said, particularly between 2012 and, for 5-6 years, there was no money in this space. So
it was a lot more challenging because I guess you had already made such big impact with these new guidelines. And as a result, people tend to just run with the shiny object.
I agree. And I still remember the worst thing that happened to me in my career is when they took these guidelines and took them to China, where there is snow and very different conditions. conditions, and they start applying guidelines from Australia in China, where, first of all, they don't have species which we have. I still remember that as a big problem because being nature-based, that means you need to look for your nature components in your neighborhood, which means you need to use your local media, you need to use your local plants, and it's really wrong to try to take something developed in Melbourne and take it to, let's say, Nanjing.
It's definitely not a one-size-fits-all solution. And
Absolutely.
you need that experimentation to figure out what actually works for you.
Exactly. And we've done that, for example, in Israel, when we got this big project in Tel Aviv. We spent quite a bit of time to tweak media so that we use local media and actually use local plants, not the same plants that we use. And then, systems we built, they are pretty good and pretty robust. So without that tweaking for local conditions, I really think it's a problem.
And actually, that example in Israel is a very interesting system. The one in Kfar Saba, for one, it's pretty big, but ideal for an experimental investigation. It treats the stormwater coming from a pretty big residential district, but it also works together with the groundwater aquifers, because is it dual mode?
Yes. The problem is in Israel, again, this is about local climate. They don't have rain for 6 months on average. So if you build a system like you build in Brisbane, where we have rain all the time, it's going to die. So you do need to water these plants. So what we've done there, and it was my postdoc at the time, Yaron Zinger, who did that, he found local wells which were so polluted that they were more or less useless. No one was using this groundwater around. And he started using that water for more or less watering. But then we discovered that we can actually treat this very high nitrate polluted groundwater, and we were putting back these, call it treated water, into shallow aquifer from which you could pump it for irrigation of a local park. So in a way, it became a very nice system, which was treating stormwater in winter when they had lots of runoff, and then treating polluted groundwater in summer, which is there available anyway. And they were putting all this water back into local aquifers, so which they can use then for irrigation. So in a way, that's again what's great about nature-based solutions. You should look not just for your regional nature, but your local conditions, and just a little bit tweak these systems to do best job for your neighborhood.
No, definitely. And I guess in relation to that, as you said, place-based approach, no one-size-fits-all, understand what your local region offers. But in a way, you have touched upon topics that allow us to be aware of what we need to then work on. So things like plant selection we've just discussed, but also other things like the clogging of systems as well.
Actually, bioretentions, but any green-blue systems, they look very simple. You just put some soil, grow some plants, and it should be fine. But it's actually very, very complex living organism. So it's never like that. Your wetlands are not like that. Your green walls are, and we've done quite a bit of work now on green walls. They are all actually very, very complex living organisms. So you need to make these, I call it plants and bugs and ecosystem in these systems happy. And that's why they need to be tweaked for local conditions to do the best work. I know still here and everywhere, there are lots of not just bioretentions, but wetlands that are not working. It's because they were not designed and often not even implemented. So designs may be good, but they were not really implemented well. And then they suffer. They don't have plants. Plants die. There is erosion. There are all sorts of problems. And it always comes from a very simple approach. Oh, this should be easy. You just dig a trench and put some soil in and put 3 plants and it'll be fine. It's not like that. It's actually pretty touchy, and there is a thin line when they do really well, or if you do something wrong, they die and don't do well.
And then it's almost complete rectification works. It's almost like you're starting from scratch again if you have
Yes, and then some of them get bad name because, I tried it and it didn't work. But then you look around the corner and, it's beautiful and it's working. So these small things make a huge difference. But I still think there are lots of challenges in design and that we do need to tweak them and make them more robust to make them less sensitive, put it this way. For example, we are working at the moment on some new generation of systems which are used for sewer overflows. That's the newest project I have here in Brisbane. And that's really interesting because when you think about sewer overflows, even in separate systems, because of climate change, because of densification, we are having these sewer overflows kicking in 10 times a year, and they should kick in every second year. So volume of pollution that comes through these systems is much worse than your stormwater. So if you, of course, get the sewer overflow through a bioretention, you will achieve much bigger load reduction than looking at just stormwater treatment. So, for example, we are now working with urban utilities here to build a first system for sewer overflows. And of course, we are tweaking designs. Designs will be different from our stormwater biofilters. And that's why this innovation in engineering, I believe, is still needed. And we still need to experiment in ways that these systems are incorporated and used in multiple ways.
Just another one of those examples where you've taken now what you've accomplished and tweaked that design to a different purpose. Another one that I can think of is where you decided to create green walls and to use a combined grey water, stormwater treatment method with these bioretention systems.
Yeah, that came because, as you know, green walls became very popular because they're aesthetically pleasing and they're used for microclimate improvements and beautification. And they're very expensive and very high maintenance. But in Australia, they honestly don't make much sense because particularly during drought, volume of water you need to water these systems is huge. I was doing some assessments that, a small school in my neighborhood that my kids went to would use same amount of water for a year that you needed for a green wall. So we started by saying, but you don't need actually clean water. And then mixed with fertilizer, you can use grey water. And Veljko Prodanovic did his PhD on this topic. And we found that grey water is doing fine and that you're getting very lush, beautiful green walls using water from showers. So that was one of the work we've done a few years back. And it's a pity that we never built a pilot. So we had a beautiful system in our green lab, but we're still waiting to install this in reality. It will be nice.
No, definitely. And I'll be visiting Veljko soon, so looking forward to catching up with him as well. He'll be on the show as well at some point. But in a way, really running away with this idea of biofiltration systems and really making it something that can innovate across the different sectors, but also you can see the multifunctionality come out of the work that you've been doing. And I think it really reflects the strengths that you have in stormwater. You are the most published researcher in the stormwater field, if we look you up. But yeah, now it's flooding. In a way, it completes that loop.
Yeah, it is, but I actually done lots of modeling as well. I've been modeler from day one. So my first paper is not first flush. There is another paper which I published in Journal of Hydraulic Research in 1997, which was on a model, hydrodynamic model of runoff. And I've been always doing modeling. And as you know, your PhD was on modeling. So that's I have true. This whole stream of socio-technical modeling, like urban beats, which we started, or Dance for Water, which we did with Wolfgang Rauch and his group. Yeah, I've been doing lots of modeling all my life. And of course, the latest one is in flooding. And the reason is because we have lots of flooding at the moment. Plus, it's not hydrodynamic modeling of floods. We started a new wave of these conceptual fast flood models. So Bezar did his PhD on the cellular automata CAFE model, which is looking really positive. So at the moment, I have a project in this space. So we are trying to use AI as everyone else to make these models even more comprehensive. So that's kind of also my current passion, to try to get some fast models that can replicate results of traditional hydrodynamic models such as two-flow or CACRAS or Mike Flood, but that they do this 10 times faster. Yeah. And I believe we are getting there. Plus, this allows us to model WUSUD, because one of the reasons why we didn't assess impact of nature-based solutions on flooding is that we didn't have really models. I still remember work which we've done with Karsten and Peter Steen, particularly Karsten from DTU was trying to incorporate WUSUD in this Mike Flood and, similar tool.
The Danish Hydraulic Institute.
Yeah, DHI. Because these models are so complex, so clunky and so slow that it's just, you can't, there are these little things everywhere and you need to run this on a continuous series which you just can't. So only using this new generation of fast flood models, you can really incorporate. And the latest PhD, which is done at UNSW, where I was working before QUT, is on trying to do what you've done in urban beats, which means to set a target for flood reduction, damage reduction, and then try to put WUSUD everywhere to meet the target.
Trying to identify a series of solutions,
Exactly, to meet the flooding target. And flooding target is about reduction of damages, so it's like, I want to say 2 million a year in flood damages, on a typical year, which means you need to run this time series, you need to, So it's a very complex challenge, but I think we are getting there because the flood models are now much faster.
I guess I quote a guest I had on the podcast before who actually referred to you, and this was Martijn, one of our students that we co-supervised. And he said what really appealed to him was when you made it clear we need to look more also at how to implement things rather than how best to do things, because we have done a lot of engineering for decades. We basically know a lot. We know how things should work, but they don't. And why do they not? And that's not an engineering question. And I guess this is really where you've really focused, apart from all the, the laboratory experiments and field measurements, really on the tools that we can use to support this. Also the uncertainties around understanding, what these outputs mean and whether we can be certain about them.
Yeah, because as you know, modeling is all about how wrong you are in your model predictions. And one of the first PhDs I supervised, we learned very quickly that I keep saying modeling without assessing uncertainties in dishonest work. So you do need to know what's uncertainty in your models and predictions. So and this uncertainty doesn't come just from model structure and, how well equations are or parameters. It also comes how good data you have, because lots of uncertainties are due to data that we use as inputs or even for calibration. So, worked I still remember in 2010 or something, and there was this big group of us from all over the world, 6, I think, different universities. We published this paper and framework, how to look into uncertainties in urban drainage models. So that was another fun work we've done across many groups, because we do realize that we do need models, but unless we understand how good they are, we actually again make very wrong designs, very wrong predictions where this is going to go.
That's true. And then the design doesn't work, what we implement, there's backlash, and then nobody wants to hear about it again. So there's a very high risk with getting the models to really work.
Yeah.
But definitely a wide-ranging portfolio in really the stormwater space. And so now going to the flood models, really trying to model a whole much greater range of time series. I guess, where do you stand on our traditional hydraulic approaches where we use design storms?
No, that's rubbish. Basically, design storms, even when I was a young girl, it was very well known that design storms are just passé. That they're absolutely not the way to do it. Continuous modeling was regarded as the way to model pipes and traditional gray systems, even I'm not joking, in 80s. So we knew that hydraulics has to be done in continuous simulations. And definitely for WUSUD, everything has to be done on a continuous, very short time steps, because these systems are small, so they don't make sense. You just can't assess the impact on a huge time steps and over a few storms. And in flooding, even we now know that to really understand cumulative effects, so sum of all damages you are making, like modeling 5 events, but definitely not design storms. That's so old. It's older than me. And I'm not young.
But I see also the importance of continuous time series, because you want to be able to run all possibilities through your system to know what's going to happen in long storms, short storms, heavy storms.
But that's why you do continuous simulation. So again, besides the work that we've done, it was done on an 85 years of 6-minute rainfall data in Melbourne. So it was the real rainfall data, and you just run it for 6 minutes and you sum up all the damages that happened during these 85 years. And you say, look, this is basically true damage. If you have WUSUD or if you don't have WUSUD, and what's the difference? So that's how we assessed. You can make lots of savings by having WUSUD strategically positioned to protect your infrastructure. And that won't be seen on 1 in 100-year event. Definitely not. But if you have lots of savings, which happens in events which are 1 in 10 years or even 1 in 5 years, it all adds up. And the fact that now with changing climate, these events are happening not 1 in 10 years, but every second year, you can even run these assessments using rainfall prediction for future. And you will see that actually savings are pretty nice. But you wouldn't see that if you just do design storms or you run this on 2 storms, which are actually causing major flooding. What we know, even in just pure, forget about Wusud, that actually some of these small storm damages can add up to the level of one of major storm that happens. So continuous modeling has been the thing for a long time. Mm-hmm. And we should keep doing it.
And we should keep doing it, indeed. And I guess with the more benefits coming into play and being able to assess, we're going to have to also be able to resolve different time steps, time frames that this modeling is happening.
Absolutely. That's why I'm a big fan of nested modeling, where you nest models depending on what they are doing or what the purpose of the model is. Because even the same model should be used in different space and time resolution depending what question you're answering. So yeah, I'm a big fan of nested models.
And where do you think we're heading in terms of now the practice of nature-based solutions? You're touching floods, which is really that, in a way, completing the water picture.
Australia went through a very interesting cycle. Basically, first it was all about engineering, and I was very lucky to be part of that. So when we were doing FOB guidelines and developing this how-to, and then at some point, and I was the first person who was saying we should do more adoption and social research and see what are the barriers in governance and how we should implement these things and find solutions in supporting councils and urban utilities to adopt these solutions. But then, funnily, like everything else, pendulum went on the other side. And then our colleagues from social sciences, where I was very, very supportive of getting them into this, start saying, oh, actually, it's all about social problems and we don't need more engineering. And in Australia, there was a period like 5-6 years ago when they stopped funding research in engineering because everyone was saying, oh, it's all done. We know everything what we need to know about engineering. It's all about social science. And at that time, I started doing what I was doing. I started doing a bit of flooding and some other stuff because flooding, there was always, sorry to say, money for flooding, and kind of stopped doing development. No, I got quite a few grants from overseas. Yeah, I was lucky to get big grants from overseas because in Australia, they were saying everything's done in engineering, but luckily we got quite a lot of grants from overseas to continue research. Interestingly, only recently, in the last couple of years, I'm hearing industry screaming and saying, oh, we do need engineering research again. And actually, we don't know this. And these systems, if you just take ANA's guidelines and take them into wrong areas, into areas where they're not working, which is true. Particularly that incident with China is still a very weird situation. So in a way, I think pendulum's coming back, and that's good to know. And people are saying we do need to perfect these designs and do them better. So it's good for me in a way.
So we're not quite done with the engineering. There's still plenty to do.
No, there's so much to do. These systems are pretty new. If you think on a historical scene, we've been building bridges for centuries, and Wusud's been pretty recent innovation. And particularly, I believe it's very touchy and very sensitive. And to get it right and well, you need to really focus on your local environment and your local opportunities.
No, definitely. But with that also means a lot more potential for new students to come through your mentorship.
Listen, I think I graduated 45 PhDs or something, some ridiculous number. I'm getting a bit old, but yeah, I always enjoyed working with PhD students. And there was time when I think I supervised like almost 20 at the same time. But yeah, it's been always very rewarding to see young people like yourself coming into my group and then, finishing and going and having great life. I must say I'm still a rare person, I would say, that stays in touch with majority of his or her PhD students. So I still actually do talk to lots of them.
No, definitely. And we're always happy to keep in touch. But I think one thing that all of us, and in preparation for this show, I did make quite a few phone calls across, across the board. But I think one thing all of us do appreciate is how you mentor us on the area of research independence and building a research career. Maybe you can illustrate what for you makes a good researcher.
Independence. I actually...
Let's unpack that a bit.
It is definitely independence, because the whole point of training is that you unlock your potential. And your potential is something that you can realize or not realize. And becoming a successful researcher means that you as a person can use the best your strengths and weaknesses. And I was always trying at the start when I get a new PhD student to understand exactly strengths and weaknesses, in which direction this person would go and flourish naturally. So that was the first thing I would observe and try to match the project with the student or student with the project, put it this way. Because all of us, starting with myself, have our strengths and weaknesses. And I have this beautiful T-shirt, which my husband bought for me for Christmas, which says, I'm engineer spelled 3 times in a wrong way. But then at the end it says, but I'm good in math. So in my case, if anyone asked me to do anything in languages, I would, I'm dyslexic, it would be disaster. So me trying to do PhD in languages would be total disaster. But I was always good in math and physics. So that's why I'm saying you need to find the strengths of the student and then unlock them and get them to own, not just their project, but to own their path where they want to develop. And it's a beautiful process. I had 2 children, as you know. So I always thought of my PhD students as exactly as you're teaching them to walk and then run. And then by 3rd year, they are much faster and better than you are. So yeah, it's a fun process. So it's like having another child.
It's a beautiful journey to be able to, I guess, go through this over and over again, year in, year out, and rewarding as well.
Yeah, it's very rewarding. And I must say, I'm getting a bit older. So as I was getting older, that's why I'm Dean of Engineering now, because I realized that apart from having PhD students and teaching them all this stuff, you can also have younger colleagues and teaching them how to become top researchers. So that's what I'm very passionate about. I've been Pro-Vice Chancellor Research of UNSW and running, for example, amazing program there called Scientia, where we gathered 100 best young researchers at UNSW, and I was basically running a program how to develop them to become research stars. Or here, where I'm Dean, we are trying to do similar, even with all the established researchers. So I always enjoyed that sort of helping whoever researcher to go and become very successful. I keep saying, if you are doing that job, then you get some, if I go and apply for grants, which I applied so many times, okay, you win a grant, so it's another grant and another grant. But if I have, and it happens a few times a year, but if I have my PhD students and then younger colleagues and I help them that they win a grant, then it's every day because there's so many of them and or published papers. So I am actually now in this stage when I get a really big kick out of helping younger people to become successful researchers rather than just me chasing.
Yeah.
And not just PhD students, I'm talking about early career researchers, mid-career, and even old, even professors.
And it's really a kind of exercise of passing on your experience. And in your case, you obviously have collected successes and not so successful aspects throughout your research. But I think one thing you have been able to do is really to match or to identify the needs of the industry at the time with high impact, deep research and your own personal interest.
It's true, but I was very low on my personal interest. I come from a background and culture where you actually, because of all challenges we had, I never thought of that. Like I used to say, it makes no difference whether you work in sewage problems or you're working on space shuttle development, because they're all problems and they're all very complex and interesting from a mathematical point of view. But I never was big on basically whether that looks sexy, if you know what I mean, or it's just like, okay, sewage. It doesn't look that, but it's actually very useful and important. So I never had that sort of, call it idealistic view. I should be working on some,
You were attracted by the math, the problem solving, rather than the application.
And problems are similar. It sounds silly, but if you are writing equations, complex hydrodynamic equations for flooding or for transport of solids in sewer, they're still hydrodynamic equations. So,
in the end,
but also maybe because of my background and where I was brought up, you just don't think about that. Like nowadays, I find people, they think about idea rather than the process. I was always more interested in the process. It was more fun for me. But of course, it's great. All I was always doing was in the area of sustainability, which is great. That's the only way for us to survive the challenges ahead.
But that, I guess, aligns one of the three elements I mentioned. So if you're more process focused, then in a way you enjoy it anyway. But then what specific strategy, was there a specific strategy that you used to really garner that industry attention to your work? Because you've been very successful.
Because I'm an engineer, and I believe that the main difference between us and science is that we always look what industry needs more or less now and listening. Because industry will tell you where their challenges are, and you need to also guide them where they will be a little bit ahead of that. But unless you listen and unless you work with them closely. So for me, it was always to work with industry very closely, to listen and to understand their needs. And that usually leads to success, because in our area, research money usually is in industry. I mean, these days, I'm of course getting Australia Research Council, but they are peanuts comparing to money that I used to get from industry, because they have a need and therefore they pay. And the problems are real. They're not philosophical. They are real problems. And then it just makes sense. And I personally get kick off building things. So when we built all these systems, it's really fun to see things being built, not just I published the paper.
Impact rather than impact factor.
It's both. I used to say, look, our 4 design guidelines, they were built on 30 journal papers in top research journals, like every second was in water research. So in a way, I'm big fan of get your industry guidelines or your industry outputs by first publishing in top peer review journals, because that's how you will get that sort of assurance that these things are real and good quality. And then you would distill them in a simple rules for industry in the way, because industry won't read your papers. So I'm a big fan of dual approach.
Yep.
Because one without the other is wrong. Because I've seen, again, some people who just worked with industry and never actually validated this with their peers, and it didn't go well. And I told you about the first version of design guidelines in Australia of biofiltration. They were written exactly in that way. And industry started using them when actually they were totally wrong. And the other way around, where people just publish papers and never get all that into some useful format or even synthesize that for industry so it never get applied. So as I said, I'm a big fan of both. So my group, as you know, always published a lot and still publish, but at the same time, we also publish these very specific distilled products which industry would use.
As I said, perhaps the most published person on stormwater management, but also with a lot of policy documents and design guides and related documents to her name as well. So
thank you.
Very fascinating career so far. And I guess one other fascinating aspect you've also advocated for is the role of women in engineering. And you've been a very big advocate for supporting women in engineering. And you yourself have also, I guess, joined that kind of discipline when it in the past has been very male-dominated.
Actually, I come from communism. And in communism, it was not as rare as in the West. And when I was studying civil engineering in late 80s, we did have, honestly, much higher percentage of women in engineering than here now in Australia. But what happened is that, as I said, I come from a long line of engineers. And even, as I said, my mother-in-law was an engineer. So that was not so weird. Having said that, it was still male-dominated. And it was even in Yugoslavia, although we had lots of women in engineering, there was absolutely open sexism and open, like my first job I didn't get because basically, although I had a scholarship, the guy told me in my face they won't give me a job because I'm a woman and I will have these kids and I will never work to my full potential. So they said, we had to give you scholarship because I had good grades and it was all merit-based, but we are not going to give you a job. So it was very open. But you know me, I'm pretty robust person. So usually I get angry. I don't get emotional in any other way that I get angry. And then I basically push through. And some even people who were telling me openly that I can't make it. A few years later, we became the best friends and they still respect me as a scientist. So I would prove them wrong through this robustness because it's just... Otherwise, you just crumble if you start crying. When I moved to the West, I was so surprised that there was not that open sexism. There was sexism, but nowhere as bad as in Yugoslavia or in the Balkans. But there was actually no women. There were no one. I was the first lecturer in engineering, any engineering at the University of Aberdeen, which is almost 500 years old.
Wow.
It's actually more than 500 years old. So in this College of Engineering, which had famous Maxwell as one of the first professors, I was the first woman ever in engineering. And then when I moved to Monash, I was the first female lecturer in civil engineering and stuff like that. So it looked like I was the first. And there was sexism in those days, even in Australia, but far less open than in Yugoslavia. But it was still there. So I did spend lots of time in those days trying to support women to do PhDs and to stay in academia. And at that time, half of my PhD students were girls at the time. And when I won Victoria Prize, it's kind of Scientist of the Year for Victoria. I was the first woman ever to win Victoria Prize. The prize was given for 30 odd years. I can't now remember. So I was first ever female scientist to win the prize.
This was the Victorian Prize for Science and Innovation in Physical Sciences.
Yeah, but it was funny that before that, they never had a woman. So it was all first. And I did spend quite a bit of time. We ran these series of conferences. I now remember every second year we would run, I call it survival course. We would get some sort of sponsorship for, last time was 150 female academics in engineering across Australia. But I must say, I stopped doing that. And the reason why I stopped doing that lately is that I think the battle is won. Interestingly, if you look data, Engineers Australia is publishing data every year on salaries. At the moment, if you are a female engineer, you get roughly $5,000 plus $1,000 more salary than a boy. So graduate salaries for girls in Australia for the last 6-7 years been higher for female than male.
Wow.
It's only graduate, of course. It's going to take time before that filters through the ranks. I know my daughter, when she finished engineering, that she was given like 3 offers and they were way above offers that boys were getting. So in a way, I know, and she's saying openly that at the moment she's got more opportunities just because she's a rare female in that male-dominated area. So I personally think these sort of structural problems are gone.
Yep.
And that girls are getting more opportunities even than boys. What worries me is more like what happens when you get babies and that sort of support structure down the road. So that's still a problem, but I would think that's a problem which is more for, I would call, equity in your family rather than outside in the workplace. Workplaces are now doing a lot, far more than ever, to keep these women and definitely to get them, because diversity is recognized as a good thing, an important thing. So I think we are there. I personally think we are there. And sometimes I even feel for boys.
Okay.
I have a girl and a boy. And sometimes I joke I'll become a fighter for boys' rights. And the reason is because it's necessary, and we've been doing that, and it's fine to do positive discrimination. And it's looking good on a big scale. But for a boy who missed it because of the positive discrimination is very hurtful. And it's very interesting to see. Again, it's a pendulum. It will come to where it should be. But sometimes it's actually, I feel for boys.
Our world is a pendulum. It's a very powerful image in my head where I think any change in this world is on a pendulum.
Exactly.
And we try to push it. And if we push it too hard, we then have to counteract it.
And it's happening. Like, I can see that happening. And I hope, I think it's necessity, but I would like us to acknowledge the necessity and acknowledge the pain that it may cause to some boys. Because, for example, I'm running in my faculty 2 new positions in the School of Electrical and Robotics. And we made it very clear it's for women only. And I think it's better if it's women only, so we know we want a woman and there is no discrimination. That's it. But you may say that's not fair. There's so many boys who would like to become lecturers, but they have zero chance because they can't even apply.
But at least it's transparent.
It's transparent. That's what I prefer, transparency, rather than we say we want lecturer in power engineering and you apply, but then you have some amazing individual who happens to be male and you have not that great, but you want a woman and you just give that's actually, I just don't like that. It's a fair game. It should be fair game. So that's why I am a big fan of women-only positions in areas where we don't have them, like in electrical. Actually, I doubled the number from 2 to 4.
Oh, wow.
And now we're talking about another 2, so we may have 6. But once it comes to some real numbers, I personally will stop doing that, because once you start having healthy 30+% of women, then it should be done in a natural way. Yeah. Having said that, I still feel for boys who actually at the moment, because we have this huge push, which is important and necessary, they miss out.
But I guess opportunities will spring up. It's really that pendulum. And at some point we will notice when the pendulum will start to stabilize.
Yeah, but we should acknowledge.
Yeah.
I am big for acknowledging when we do this. And also there are so many good girls, so we should not do negative selection. Positive discrimination is fine, but not negative selection.
And so we'll see what the future holds, but it's certainly very noble work. And I think, in a way you can feel happy about what you've accomplished to this point in that regard.
I think huge change. I know some girls who are now, they actually, it was rough 15, 20 years ago much. And now we come to the point where it's recognized. And that's fine. But we have to recognize also, we have to think about diversity in a bit more comprehensive way.
Definitely. Inclusion, diversity, equity, everything in this world. This has been super fascinating and really learning a lot more also about things that I didn't know about you. So for me, it's also been a very heartwarming conversation. And I still have a few final questions to finish off that I ask all my guests. And I guess the one that kind of suits with all the experiences you've had, we've talked a lot about the pendulum as well. If you had a magic wand, if you could change one thing about the world right now, what would it be?
It's interesting. I think where we live, which is developed world and very wealthy, we are having, I believe, and data show, we are having more, the middle class is kind of not disappearing, but we are having far more wealthier people, and middle class is kind of becoming less relatively wealthy, if you know what I mean.
Yeah.
And these opportunities is what bothers me a lot. So at the moment, I'm focusing a lot on trying to help kids from areas which are, call it low socioeconomic, and particularly areas where there is lots of immigration in Australia, or people from, we call them often first in family, to come to the university. So I just won this award, Wonderful Woman. We are investing quite heavily into this program with a local school here in Brisbane. It's actually a school with the highest proportion of Aboriginal kids in southeast Queensland, and also lots of refugees. So we are trying to bring them over to QUT so that they experience university, that they see what it means to do, not engineering, but any degree, but particularly engineering if we can. So we do invest quite a bit of time and a bit of money to bring these kids here every second week. They do very interesting projects. At the moment, we have 45. Half of them are girls, quarter is Aboriginal kids. And these are the kids who would never, ever even come to a uni, just to visit even.
Yeah.
And we're giving them opportunity to experience that. And interestingly, we run these events with parents, because often parents are the main people who will say, why would you study? You just go and work and do something, like bring money. So we also provide pathways for them to go through a college instead of directly to uni, because our ATARs, our entrance is getting
grades
higher and higher. And it's not easy to get into. So we are providing these pathways, alternative pathways, so that they do first year within more supportive environment. So we're doing all that. And I was so pleased to see first cohort now coming through this college into engineering. of girls in this case who would never ever think about doing uni, forget about engineering, and knowing how much they can earn once they finish, and in Australia, engineers are paid pretty well, this is going to change their lives and lives of their families. So I personally, at the moment, I'm very passionate about trying to support this type of projects where we are trying to support people who had different start in life.
Well, that's really beautiful.
So that's another thing which... And that's, as I said, unless we do more of that, it's really hard, because even hardworking families, if they are from that sort of background, it's not easy.
No, that's really beautiful. And sounds like you don't really need the magic wand because you're just acting on it now.
No, it's a magic wand. It's a magic wand is that we don't have this. Like in Australia, for example, one of the biggest problems for me is private education. If you go to Melbourne, I think they're talking about 40% of all kids going to private paid schools. And you have actually two-tier system, and parents are struggling to even pay for that. And then you have segregation, and it starts in high school and it never finishes. And I believe that we need less segregation and bringing education to people, and that changes their lives. True. I keep joking, my daughter's fourth generation of engineers. So no one had to tell her, you need to go to uni and study something. But these kids, they've never seen anyone with a degree, so very rarely. So they need that support. So yeah, if we stop that segregation would be nice, but it's actually becoming worse.
In a way, opening their minds and showing to them that it's possible.
Yeah, and confidence. It's a lot about confidence, because lots of these kids can do it, but they don't believe they can.
Yeah. Is there a key moment, book, paper, or event or person that completely changed the course of your career or mindset at some point in your journey?
Not career. Maybe the most influential event that happened in my life was going to Srebrenica a week after massacre there. So I was in Serbia, and then there was this big thing that happened in Bosnia, and it was all about water. The Bosnian army blew up water treatment works there, and then when they took back Srebrenica, they needed someone to fix the treatment works. And me being always very adventurous, when they came and said, do you want to go and help with this? I went. And I always wanted to help because, to be honest, at the time, there was this terrible thing happening in Croatia called Oluja, when Serbs were pushed out. And it was a mess. So they were thinking, I think at the time, they may populate this town that was cleaned of one nation of my country with another. So I went and saw, I spent a few days there, and it really, really made a huge impact on me. A few months later, I left Yugoslavia. I just said, I don't want to live this. This was a mess. And just, seeing that level of suffering and seeing what wars can do to people, normal people, it was a it made a huge impact on me. And still, some of my PhD students, when they are going through very hard times, personal times, career times, or whatever, heartbreaking with their partners, or they're having career lows. Still remember one of them was saying, oh, how do I cope? And tell me, how do you cope when you have some terrible moments? I just remember Srebrenica. Everything else looks so simple and so nice and no problems. Wow. So you put everything in perspective of a war, massacres, people being killed, moved, dislodged, and stuff like that. And I'm not talking like the whole region there was a mess, and they were just doing to each other. Depends who was better at the time with guns and bombs. So when you put everything else in that perspective, everything looks simple and very, very not important. So that made a huge impact on my life. A few days in the war zone.
I remember visiting Serbia back in 2012, and I could see some of the remnants of it in Belgrade. And I guess, just hearing that story, it sends shivers down my spine. I tend to ask my guests also what is one of the most challenging situations that they've ever faced in their career. And I guess this would have been not just career.
It was not challenging in a way. It was more emotional and more like I saw this with my eyes. I spoke to these people. They told me stuff. And you're just thinking, is this like, yes, we lived in Belgrade, but Belgrade was bombed in 1999. And then it was bombed. This was massacres on a different scale. The whole region was traumatized. And then the problem there was that normal people, nice people, very, very lovely people would not accept and not openly discuss or believe that these things happened. So that was the reason why my husband and I decided to leave. You couldn't have conversation, even with your friends, about these things in a, I call it, factual, rational way. And still you can't. And in a way, that's really awful and hurtful. And my career, I don't know, it was always, there were up and downs and there were things which were not nice. I actually have a very simple rule. 6 months of not being happy is enough. So if I live and work particularly, but in life, in everything. So if I'm at a place, let's say, and Monash was a lovely place for 10, 12 years or whatever. And I was happy and fine. But when things are not, at least I'm not happy, and I'm not saying they're wrong. It's just I don't feel good. Within 6 months, I'm gone. And I think that's because I left my country, and I keep joking, I have 3 citizenship and no country, because the country that's there is not my country. It's basically went into flames because I was born in Yugoslavia, and what's left there are 6 countries. So I don't think anyone should suffer more than 6 months, wherever. So in a relationship, in work, so it's like you try it and then you just go, because there are other places. And me moving from Yugoslavia to Scotland or Scotland here, or, I moved from Melbourne to Sydney, Sydney to Brisbane, and, commuting up and down makes no difference. What makes difference? The time. And there is no reason for staying and suffering. Whatever the suffering is, whether it's work, relationship, you just move on. And that's been always it's a temporarily, but it's very small.
That's absolutely fascinating advice. And I guess it makes sense. Life's too short to feel sorry for yourself.
You're just like, and there are opportunities. Every time I moved, actually, I personally learned something. I had fun. It was much nicer. Like, actually, sometimes I believe it's good that this thing happened, because I would not have moved.
True. When you look back on things, you think, well, it was a tough time, but you feel stronger for it.
I never thought of feeling stronger. I thought it gave me a reason to look for other opportunities and to move and experience something new.
Yeah, very true.
So, yeah.
And it's also getting out of your comfort zone, really.
I get bored. That's my problem. I get bored. And if I don't change and do something new, I'm just too bored. And that's another. Life is too short to do same thing again and again. I used to joke that there are some researchers who've been writing same paper for 30 years. So in a way, that's why I think you need to change your topic in a certain way every 5-ish years, maximum 10 years, honestly, and then move on. You need to, I think, even where you live, that was mine, to move and change, because you experience so much when you change an environment. The only thing I have not changed is my husband.
Oh, well, that's and he's absolutely lovely. And I look forward to meeting him again very soon at some point. So, and people call you Anna the Tornado, Anna the Whirlwind, because you enjoy what you do, you manage things, and you somehow are so able to multitask and raise 2 kids and do a lot of stuff with your husband. You played volleyball on the weekend. What tips can you offer in terms of time management? How do you balance that professional and personal life?
I don't know. It's also very natural, comes to me. It's about what you don't do. I think to become efficient, efficiency is doing impactful stuff. And I think same in research was always, you can do lots of stuff, but it's more important what you don't do, and pick stuff which is very impactful in anything. So I was always looking for, if I do this, what impact that will do. And if I do this, that's obviously lost opportunity for doing something else. So you have to wait opportunities and they say, this one will make impact and this will not. Why would I do this? I'm also very big on cutting, I call it crap. So there is lots of stuff which people do just because they have to do and they feel obliged. I never feel obliged to do anything. So in a way, if I don't think this is useful, I would actually be rather vocal and try to, in a nice way, explain to people why I'm not going to do it. So I think picking what you do it well. And that was another thing, that whatever you do, you need to do well. not mediocre. And then making impact with that. And then you don't do stuff which you don't believe can make impact. And I have lots of energy. That's also genetic.
Does it come from the Coca-Cola or?
It doesn't matter. I inherited this energy from my father, similar. So he's still with us and he's still running around. So it's genetic. Yeah. Like some people have high level of energy, some don't. So I was lucky.
But I think that the advice around picking the opportunities and lost opportunities is very helpful. I think it allows people to put into perspective what all the options are and to really just...
There are lots of people who pick things because of compliance. I call it compliance work.
Okay.
And I think that's wrong. Like, you don't achieve anything. Okay, you sit on this and do this and, but it's a compliance work. It's not impactful work. And also, if you pick something, then you do really good job out of that. And then people see impact and you see impact and you feel good.
No, very true. Anna, it's been absolutely enjoyable. And yeah, I'm just so happy to reconnect after 3 years, even though we have seen each other on Zoom. In 3D is so much better. Where can people reach you if they ever want to get in touch?
Well, everyone can Google me and find me. And even if I move again, you can easily Google me. You'll find me where I am at the moment. I'm at Queensland University of Technology and I'm having a ball. I really like my job and my life.
Yeah, and we'll put this and links to other things that we discussed today in the show notes. But like I do with every guest, I leave you the last word, one message for the listeners to take away from today.
I just think, as I said, do not suffer. Just change things. If you don't like them, just go and change them. And you can always change and you can move on, leave, even change, not leave, even stay where you are, but just change things, how you're doing them. And it's always, I really don't think suffering is a good outcome for anyone. Don't suffer.
Thank you very much. And thank you to you listeners for tuning into this deep, entertaining and memorable conversation with Professor Anna Deletic. As mentioned, you can find links to people, papers, Coca-Cola facts and cover photos in our show notes over at petermbach.com/podcast. If you enjoyed this show and are looking forward to more episodes, please do subscribe or follow this podcast on Spotify, Apple Music or wherever you are listening from to be notified of the latest release as soon as it becomes available. I would be incredibly grateful for this as it helps me to reach a broader audience and, who knows, perhaps inspire more researchers to search inward for their core strengths or just more conscious awareness of how to prioritize making a difference in the world. If you'd like to know more about me or my work in general, you can also check out my website at petermbach.com, my YouTube channel, Peter Marcus Bach, that's Marcus with a C, or follow me on Twitter at petermbach or Instagram at petermbach87. If you have feedback or suggestions or just know someone who has an inspiring story to offer, please feel free to reach out to me on social media. The podcast's intro and outro song is called Picolia by Bureaucratic. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.